Hello everyone and welcome to this presentation. Today we're going to cover the design of goods and services. This is part of the industrial engineering program. So first of all, let's talk about a new product development strategy. Uh, um, it consists of developing new products through the firm's own research and development efforts, the research and development department. Um, and it's important to always keep developing new products and keep inserting new products into the market since we need to keep up with the advances in all the products in the market in general. So, creating a successful new product requires understanding the markets first, understanding the competitors, the consumers, how's the market changing, how's the company is changing, um, understanding consumer behavior, and then developing products that deliver superior value to consumers. So we need to understand first, and then to be able to develop products that are superior for the customer. So some product changes. So some examples are DVDs to video streaming, landlines to cell phones to smartphones, and then the Internet of Digital Information to an Internet of Things that connects you and your smartphone to your home car and doctor, etc., all your appliances at home. And to develop a new product, there are some stages, and we're gonna go through these stages. Um, Basically, this is the way we can generate ideas and concepts. If you want to, just say, I work at 3M company and we want to develop a new product. Okay, so first we have an idea of some new product that we want to add. Okay, and we want to first ask. Okay, let's say I work at Amazon. Okay, I want to develop a new product that's never existed. So I want to develop um, a smart. Um, okay, no, not Kindle. I want to develop a smart. A smart water bottle. Why would I want that? Not sure, but I want to develop a smart water bottle for Amazon specifically, and I wanted to connect to the internet. I want to be able to connect to the internet so I can get some data from this water bottle. Maybe it can measure the nutrients and calories in my drink. If I'm making a smoothie, I can put it inside and then it measures the calories for my smoothie. So this is my idea. Now we want to ask, is this feasible? Is this idea feasible? I'm not sure. Maybe it is, but it needs some research. We need to do some research and in order to know if this idea is feasible. So, and there's concept testing, testing new product concepts with the groups. Yes, we want also to test some concept. We can try to make a prototype and give it to a group of people, see how they react to it. So, first of all, the first idea. So yeah. So and also if we said that yeah, if we said that the idea is good and can be it's doable, feasible, and we can go through with the next stages after constant review, feedback, and evaluation. We need to minimize failure, so we don't want our product to fail. We need to make sure this product is um, appealing and also is practical, is feasible. Okay, so yeah, so if this product we say it's feasible and it's practical and consumers want them, then okay, we can go for it. So we have customer requirements to win orders. Says now we are deciding what are the customer requirements. So if you go to the customer and ask them, what do you want in your smart water bottle? Do you want it to measure the level of water in it? Do you want it to measure some minerals? Are you worried about some minerals in water or some leftovers? Are you worried about that? Maybe you can ask them other questions. So this can be done, and in different ways we can do that, which is we can do surveys, we can go ask the customers, ask experts, and so on. And after that, after we decide what are the requirements, we're gonna then go to functional specifications and how will the product work. So this is gonna be a detailed, um, it's gonna discuss the specifications of the product, how will it work, what will it have, what features will it have, um, what the customers want. Based on what the customer wants, we can develop some specifications and features. And then we're gonna go to product specifications and manufacturability. This is how the product will be made. We need to discuss this. What materials, how much time do we need, what resources do we need, etc. And then we're gonna go to the design review after we have manufactured, or let's say after we have decided the product specifications and manufacturability. We're gonna then go to design review and ask, are these product specifications the best way to meet customer requirements? Okay, and we can review our design. Okay, so this is all a scope for design and engineering teams. That's what they do here. And then after we review the design and say, okay, this is the suitable specifications for the customer requirements and everything, and we want to do this product, then we can test the product, test the market, and go back to the customer and ask them, does this meet your expectation? Now, after we develop this design and design this product, does this product meet your expectation? Let's ask them and see. And then we go to try. After we have the product, we introduce it to the market, and we of course train people to sell this product, promote it, and channel decisions. And then we evaluate, was it a success or a failure, and then we can, based on this evaluation, have some idea. Sorry. Okay, so we can go to my notes. So um, as you can see, this is almost the same concept. So new product development process. This is the process of developing a new product. First, we market, we convince the customer, try to differentiate and segment. First, identify the customer. We segment the market, identify who are we aiming to sell to, and then identify the customer's need and requirements. Then we go for requirement engineering, which usually takes months, but it's the most important part of the whole um, product development process. So, for example, in this example, if you want to develop a new phone, what would be the requirements? We would say long battery life, better camera, responsiveness, and lightweight. And then we yeah, have pixels and stuff like that. So lower space line, yeah. And then we have the other stage is So and then we have concept design, which is can be done on CAD or hand drawings. So for example, this was a design for a chair that is different than other chairs. Okay, for a restaurant. So and this is the job. The concept design is the job of the R&D employees, customers, and of the R&D, and we get the idea from also employees, customers, and consumers. So Yeah, and then we go for the detailed design. After we have the concept design, we go to the detailed design, which covers the dimension, content, material, and then we go after that. After we designed, we develop a prototype and test it. So testing a prototype, so we test, fail, and then repeat. And then we have also the process design, which covers the location, layout, supply chain, quality inspection. So this is um, designing or preparing for distribution and sales. So we decide what's the location, the layout, the supply chain, how it's gonna be produced, and then quality inspection. And then 7, we're gonna go for distribution and sales. Okay. Now, quality function development. Now, quality function development, QFD, determines what will satisfy the customer and will translate those customers' desires into the target design. And there's house of quality, which is utilize a planning matrix to relate. Okay, yeah, so house quality is basically we're gonna develop a matrix, okay, to try to meet the customer wants using some criteria. We're gonna see that now. It's a function, and we will need to determine first what we'll do is we need to determine what will satisfy the customer and what the customer wants, and then we're gonna translate those customer desires into the target design. And identify what the qualities of the product are going to meet the customer's need. So, and there are some steps, quality function development. The first steps, 7 steps. So the first step is identify customer wants, and then identify how the goods, services will satisfy customer wants, and then relate customer wants to product house. How are we going to meet these wants? Identify relationship between the firm's house and develop our importance rating. So the importance of each how is gonna determined by us, the engineers, the company, and then evaluate competing products, compare performance to desirable technical attributes. And this is basically the quality function deployment house of quality. So this house consists of the relationship metrics, the competitive assessment, weighted rating, target values, technical evaluations, what the customer wants, customer importance rating. It's very huge in this house, and how to satisfy customer wants, and then interrelationships. Okay, let's see. So, house of quality example. Let's talk about an example. So here we have a camera, and my team has been charged, or your team has been charged with designing a new digital camera for great cameras. Okay, so the first action is to construct a house of equality. So, and the house quality is basically the structure. This is the house quality structure. Now, the house of equality, we want to decide what the customer wants. This is the light blue part of the house of quality. So what the customer wants, this is our basis. Okay, we need to start with this. Okay, because we are um, at the start and at the end we are um, developing something for the customer. Okay, so we want to decide what the customer wants. Does he want lightweight, easy to use, reliable, easy to hold steady, high resolution? These are all metrics. Okay, and we have also the customer importance rating. So this can be gathered from surveys, asking the customer directly what does he want, Does he want, for example, a lightweight camera? Does he want it to be easy to use, reliable, easy to hold, steady, high resolution? So we're gonna ask, for example, I'm gonna go to the streets and ask someone, tell him, what would you like a camera? So what are the most important metrics in a camera for you, or the most important aspect? Is it you need high resolution? Do you want it to be easy to use, reliable? What do you like about a camera in general? And they will tell me, they will give me some metrics. Okay, and then I'm gonna ask him of this, of the importance of this specific metric with respect to others, and then this is gonna represent the rating. So we can basically do questionnaires and surveys. And here the lowest rating is the least important, and for the high state rating 5 is the most important. So for the customer. And then now, after we have developed this rating for the customer, now we need to develop um, requirements. So now we need to develop these requirements. Okay. Now these requirements are developed by engineers based on the responses of the customers. So these include the electricity requirements, aluminum components, autofocus, auto exposure, high number of pixels, and ergo, uh, ergonomic design. Yes, and these are decided by the engineers, not the customer. Okay, and this is when we ask how to satisfy customer wants. This is how we can satisfy customer wants by developing these features and yeah, developing these features. So this is how we satisfy customer wants. Then after that, we're gonna develop this matrix. What is this matrix? So basically, this is the relationship matrix. Okay, so it relates, um, it relates the customer wants with the house that we, or the ways that we developed as engineers to meet these needs, and we're gonna then assess based on these needs and on the customer's wants, how each need or each method of satisfying the customer wants, um, how does it rank, or how effective is it in meeting the customer needs. So how effective one of these methods is in meeting the customer needs. So for example, let's say here, now he is saying that if you have a circle with a red dot, there is a high relationship, and a red circle only is the medium, and black dot is a low relationship. So here we have 1, 2, 3, 4, 5, 6, 6 columns, and here we have 1, 2, 3, 4, 5, 6, 6 methods of meeting the customer needs. So these are going to be on top here, okay, and we're gonna relate them. So lightweight has a low relationship between having a lightweight camera and having low electricity requirements. Okay, we can then go, for example, reliable. There is a medium relationship between being reliable and having autofocus. So autofocus is part of being reliable. Okay. Also, we have now, if we want easy to hold, steady, there is a high relationship between the camera being easy to hold and steady, and the ergonomic design. So there is a strong relationship between these, and then there is a strong relationship between high resolution and having high number of pixels. Okay, so and then we evaluate based on each metric, and this is done by the engineers in the company. This is done by engineers. Okay, and then as you can see, this is the house quality. This is the relationship between the things that we can do, and yes, so this is the relationship here on top. and these are all related, and then we can give numbers to each of these and evaluate which is safe. Now from the relationship matrix we can get some numbers. We can give it an importance rating. Okay, assign an importance rating to each of our qualities. So as you can see, the most important thing here to do based on our analysis is to have a high number of pixels. Okay, which is highly related to high resolution. Although, so this is important. Although it's highly correlated with high resolution, was not very important. It's also mediumly correlated with reliability and ease to use, and that's why it's gotten a big rating, or a big rating, because ease to use and reliability has a big importance to the customers, since they have a higher number here, a higher rating, and also then we have. Um, having auto exposure and autofocus are important parts also, and also the ergonomic design is important, and the least important of all of those is having aluminum components apparently. um, and so we can, based on this importance rating, then design our product and plan ahead to make sure um, we have these products or the customer's needs satisfied, and yeah and then we're having yeah and we can also try to assess how do competing products meet customer wants. Can assess companies, other companies that produce it. So company A, company B, these are some companies. So analysis of competitors is important also. So and now let's talk about new product failures. Why do new products fail? So maybe one reason it could be an overestimation of market size. So one example is for left-handed. So personally, I'm left-handed, and I've noticed that there are a lot of products. There are not many products for left-handed people. Although maybe I noticed a lot because I'm left-handed, so I would be interested. But in general, I know a lot of people who are left-handed and they don't use their products. So, for example, there is a left-handed mouse that I think exists, and there is a left-handed keyboard, and there are a lot of left-handed items that are produced. However, the number of people who are left-handed is just like 10% of the whole population or something like this. And if a company decided to produce a product for these people, then they are overestimating the market size, which is an issue because no one's gonna buy it and the product is gonna eventually fail because sales are what makes products successful. So and there are also product design problems, and yeah, having a bad design is one reason why products fail, and then advertising plays a very crucial role. Advertising, marketing, and sales, and then we have being pushed by high-level executives, um, despite poor marketing and research. So, despite not having marketing and research, high-level executives continue to push it, which eventually makes it fail. And excessive development costs. So this product costs a lot, and maybe the profits are not gonna make up for our costs. And also the competitive reaction. Maybe competitors started to copy us, or maybe not copy us. Let's say that competitors has had better products overall, which which takes from our sales. Now we have idea generation. So product ideas, which are possible products that the company can see itself offering to the market, are developed from a variety of sources, both external and internal to the firm. Okay, so and products can come from internal sources, external sources, and outsourcing. So what are the internal sources? These are the employees, R&D, employees at all levels, not only R&D. So we are not just limiting ourselves to R&D. No, we take source, we take ideas from all employees and also external sources now, consumers, even competitors, distributors, suppliers, salespeople. All of these people are external sources, and then outsourcing, which are experts, let's say, design firms, product consultancies, online collaborative communities. These are the experts. Okay, so in a recent study, only 33% of companies surveyed rated R&D as a leading source of innovation ideas. In contrast, 40% of companies identified customers as key source, and the customer is the key source, of course, because he's the one who's gonna buy. R&D are working. This is their job. Maybe they might be interested in the product, they might not be. But if we reach to the customers who are interested in the product, then we can know exactly what they want. And then followed by head of the company business units. Okay, these are the heads, and then employees 33%, and the sales force, which is 14%. Salespeople know a lot about products, so they should know better. So, and then we have the product concept, which is a detailed version of the new product idea stated in meaningful consumer terms. Yeah. So the product concept is basically a detailed version of the new product, which can be stated in for the consumer. Now, idea generation can do crowdsourcing. Many companies are now developing crowdsourcing or open innovation, new product idea programs. So, yeah, so crowdsourcing really invites everyone, including customers, employees, scientists, experts, researchers, even public at large. You can do surveys, go to the public, go to the streets, go to malls, supermarkets, ask people, and include them in the innovation process because at the end, our product is gonna be for them. So, so we have here an example. This is an example of Victorinox, a knife manufacturer. Okay, so this is a knife manufacturer company. It used a third-party crowdsourcing network, Javoto, open innovation platform. Let's check the platform. Okay, for some reason it's not working. Javoto. Javoto. Okay, it's not working, but so it's an innovation platform. It's an open innovation platform. It can capture creative designs for limited fashion. Okay, editions. Oh, so they got ideas from people to make limited fashion designs for their knives, for their Swiss Army knife. So this is one of their knives. And then the crowdsourced design models had 20% better sales success than any previous internally created limited editions. So when you get from the customer, you have a higher chance of success in sales in your product, more than if you get ideas from only internal sources. So you need external and internal sources. So here we have Unilever Golf Young Entrepreneur, yeah, Entrepreneur Award Sustainability Hackathon. So let's go here, see this video. this looks like water. It's a waste-free package. Interesting. Waste-free package for water. Oh, that's amazing. Edible water blobs. It's cheaper than plastic. Amazing. Can also have flavors. Amazing. That's a very creative idea. I love it. And these students won the first prize award by proposing the sustainability Sunsilk shower product with no need for packaging. It's simple 25 milli capsule made of biodegradable algae filled with shampoo. A substitute to the plastic shampoo bottle. Okay, it's filled with water, yeah. So now going to idea screening, concept testing. Screen new products, ideas to spot good ones and drop poor ones as soon as possible. And some ways of screening new ideas is to write up reviews by a committee. So this is how are we going to generate new ideas? Or going to the RWW framework, real win worth doing. So the RWW is having an idea that's real, that's win, that's worth doing. And if we want to produce a new product, we're gonna ask, is it real? Can we win? And is it worth doing? Okay, this is the RWW framework. Is it real? Can this product really be produced for our smart bottle example? Is this product real? Can it be really produced? Can we calculate the amount of calories or the amount of water in a bottle? Maybe it could be possible. And also, are the customers willing to buy it, even if it's feasible? Will the customer be willing to buy it? And then after that, if we say yes, then we need to ask, can we win? So does the product offer a sustainable competitive advantage? So do we have a competitive advantage by offering this product? And also, do we have the resources to make such a product? And then, is it worth doing? Does the product fit the company's overall growth strategy? Should fit our strategy and mission. It should be um, aligning with the overall um, world goals. Does it offer sufficient profit potential? That's important. So, and the company should be able to answer yes to all three RWW questions for developing this new product idea. We have then the pain analysis, brainstorming problems and pains in an industry. So it's important because many ideas came from a pain point. And we can assess the environment, the activities, the people's life, and ask them what are their pain points and generate based on that business ideas that solve problems. Some pain points could be like opening a car trunk by carrying bags. It could be for kids' shoes not being available, or yeah, and maybe clean dust for asthma sickness. So this was really an idea that was produced by one asthma um, um, patient. So he had the sickness and he developed his own vacuum cleaner for cleaning dust. And then we have free sugar candy. That's another idea. And there are a lot of great ideas here. So examples: going to the gym, In moving houses, we can find pain points in all of these places, any places really online. So, shoes, okay. Okay, this is an example product. So product C, how we had a pain point. Okay, I love this. So we had a lot of screws in the past and they needed to be in different size now. Someone thought, why not have it in one screw and have different sizes which we can directly plug. I love this. Then we have, yeah, we had the different types of plugs, and it was a bit messy for those maybe traveling or having more than one type of socket. So one asked, why not develop a universal socket for all types of electricity plugs, and this is used for traveling, and also these people travel a lot. And we can use computer-aided design to design our product, have the concept design ready, um, CAD software and stuff like that. So it has a shorter development cycle and improved accuracy, and has basically usually low cost, and can be developed worldwide and shared easily. So some extensions of CAD through the internet, and 3D printing. These are extensions of CAD. We can do some 3D printing to test. And we have also computer-aided manufacturing, CAM. It utilizes specialized computers and programs to control manufacturing equipment, often driven by the CAD system, CAD/CAM. So computer-aided manufacturing, computer-aided design manufacturing is like 3D printing, which is aided by CAD, computer-aided design. Okay. And maybe for a product, we need some documents. These could include engineering drawings, showing dimensions, tolerances, and materials, and also could be bill of material, product structure, list of components, descriptions, and quantities which are required to make one unit of a product, and so make or buy. Assembly drawing, assembly chart, sheet, and work order. These are all documents needed to develop a product, and we're gonna go through them in the next video. Thank you for watching, and I hope you, uh, yeah, thank you for watching.